Yeah, I think we're on making good time here. So why don't you go ahead and start it out, Brian? And thanks for this opportunity to tell us what's going to happen.
Yeah, well, thank you guys. And one of the reasons I wanted to kind of do it in this format, as I expressed to Aaron, is that just the level of interactivity we can have with something like this, instead of me sending out a video and then it essentially going to one person and then it gets circulated and then emailing questions back. So with this type of interactivity, I just think it's beneficial for us all to do that. And the thing that I want to show and kind of, share with you guys today is kind of, what's driving what our long range weather patterns are like right now. Also the importance of why we need to be very diligent with the whole PR program, talking to different clients and customers about this, and a little bit of a background for myself. I came from farming and ranching country. My folks still farm and ranch, and I recognize the importance of this kind of thing. So I'm pretty much an open book. So you guys can ask me whatever you want. You might not get the answer that you want, but I'll still do my best to give you give you the information that will help you out the most. So kind of what we're going to start out with is some things maybe you guys have or have not seen. I don't know, but I still want to go over it. But one of the main reasons our weather is situated the way it is, and it has been over the past few years, is this oscillation called the Pacific Decadal Oscillation. And that's what it looks like over the past almost 170 years, where you're seeing the red spikes. That's where the Pacific was in a warm or a positive phase. Where you're seeing the blue spikes, well, that's where it was in a cold or a negative phase. So that's over the past 168 years. But during the past, say, 23 years, this is what it's looked like. So it takes you back to 2000. And you can see during that period of time, we have had a long time where we are or negative PDO, and where we have the exact opposite. When you have a cold or a negative PDO, it usually facilitates more frequent and longer lasting and potentially stronger La Nina episodes to develop and maintain themselves. And some of the negativity on the PDO during the past couple of years has actually rivaled some things that were back in say 2011, and also even back in the 50s. So this isn't just some small thing that passes by and doesn't have any ramifications on us. It has some huge ramifications, especially for the desert Southwest, the Western High Plains, and at times the Northern Rockies. And if we look at the past 2 years here, you can see those levels have been firmly negative. And this is the one thing that has really been able to allow the La Nina to continue at a fairly significant strength over the past couple of years or so. So that kind of gives you a little bit of groundwork about what some of the bigger players are in driving this particular La Nina. It doesn't necessarily mean the Atlantic is any different. The Atlantic has the same type of an oscillation, and it kind of flips back and forth about every, say, 30 to 35 years. The PDO can go back and forth every 25 to 35. You might be saying, well, that doesn't do me a lot of good if there's some variability in there about 10 years when you guys don't know when it's going to flip back and forth. Well, it is what it is. We're not talking about something like a golf forecast 24 hours from now. We're talking specifically about a body of water or bodies of water like the Pacific and the Atlantic changing decadal phases over a period of time. So when you put things in tandem here, the Pacific and the Atlantic has been in a positive phase since about 1995. What does that mean in terms of drought anomalies? Okay, on this graphic where you're seeing blue, that's where drought is infrequent. Okay, wet times in those places. Where you're seeing the reds, that's where drought is more frequent. The frequency is enhanced. So right now we are on the lower right-hand portion of your page right there, a negative PDO, a positive AMO. So where you're seeing the red, that's usually where drought frequency is enhanced. And I think for the most part, it's doing a good job. It missed the Eastern Corn Belt. You could actually flip-flop. The Eastern Corn Belt's been fairly wet for a while. The Western Corn Belt has been dry. Eastern Nebraska, Western Iowa, in those areas. And it's not a perfect roadmap, but it gives you a good idea of what to expect over a longer period of time. So for folks that I talk to specifically in the Western High Plains, I tell them, I'm like, from a PDO perspective, man, your prospects of being in drought at 75% of the time are enhanced. So in my mind, it's like, well, why wouldn't you want to take advantage of this program? Because even if you didn't necessarily pin it down to one particular interval, 2 intervals, or 3, and you just shotgunned your percentages across the board, chances are you're probably going to come out okay with something like this. Other parts of the country, it may or may not work out as well. Okay, and I recognize that fact, but specifically in the western high plains, parts of the desert Southwest, you're doing pretty well. The area of concern that doesn't have to worry a whole lot when we're talking about this type of deal is when the Pacific is warm and the Atlantic is cold, and we are not there right now. So if you have questions about this particular graphic, then we can discuss that. At other times, though, you might say, well, what about the Pacific Northwest? What makes them drier than average? Well, for one of those things, an El Nino makes them drier than average. Well, if you look in the upper right-hand corner there, a positive PDO, when the Pacific is in a positive phase, it will facilitate longer lasting El Nino episodes and more frequent. We have not seen that since the late 70s through the middle part of the 90s. Since the late 90s, we've been stuck with kind of what we have out here. Past 180 days, this is what it's looked like in terms of precipitation anomalies. Parts of the northern plains have been very wet at times. That is especially true from late spring, where they had record snow and rain up in that part of the area. Parts of the Pacific Northwest have done okay over the past 6 months or so. Other parts haven't fared as well. If you look at parts of Arizona, New Mexico, those blue blobs down there are directly attributed to the killer monsoon that they've had going on down there since early June. And then if you look eastward, there are many areas of the western and southern plains that have really struggled. There's particular problems there from southwest Nebraska through parts of west central Kansas, where they are in probably some of the worst shape out of anybody on this graphic. If you look at the past 90 days, well, things change, don't they? Look at the Pacific Northwest. Over the past 3 months, they have been drier than average, and in some cases, very much drier than average during that time. Look at the monsoon that goes gangbusters down in the Southwest, and then you still have that dry area over the central and southern portion of the plains. But look what happens here in the past 30 days. Things kind of lessen a little bit, but you still have dry spots. Folks in Texas got a pretty good rain a few weeks ago that was fairly widespread. But if you look at southeast Wyoming, western Nebraska, and northeast Colorado, folks, those are some areas that when in many times nobody's getting rain, those areas are getting rain. And they have been greatly shorted in terms of rainfall over the past several months or so. So that kind of tells you how things are right now. Now, what is going on with this La Nina thing? It's strong. And if you look at all that blue and even at times purple shading off the west coast of South America, all the way out close to Indonesia, that's the La Nina. It has been strengthening over the past few weeks. All right. The North Pacific has also started to cool down from what it was earlier. And as we get into the seasonal change and we shift these blobs of water around, that's going to have a great impact on how this winter shakes out. And obviously we head towards spring. But one of the main drivers that we can sink our teeth into is the strong La Nina that's continuing right now. I don't see this thing going away really anytime soon. And the probabilistic forecasts right here clearly show that. So where you're seeing the blue bars, especially, all the way through November, December, January, you see those probabilities of La Nina being here at 80%. We don't drop below 50% of a La Nina still being here until February, March, and April. Historically speaking, that's when La Nina starts to fade. Last year, that La Nina episode was fading in January and February, and then got a big boost that kept it around and kept it fairly strong during the course of the summer. Do I see that happening this year? I don't see that happening the way I see it right now. I think it'll weaken and we'll probably come back toward neutral. But the problem is, even if La Nina weakens, we've got to warm up that PDO out there, because if that PDO stays at those negative or those colder levels, it makes it just that much easier for a La Nina to come right back. All right. So that's something that I'm going to be watching very closely. But every model that I have looked at ends this La Nina late this winter and early spring, and actually trends us toward some sort of an El Nino event as we head into 2023. Again, this is still a long ways out there, and we still have a ways to go. As I said, I'd like to see the PDO warm up before we talked about that, but that's kind of what we're looking at right now. Another driver is I'm going to spend a little time on this. It's called the Madden Julian oscillation. This is tied to thunderstorm activity over in the Indian Ocean. And when these big storms get going, this circulation sends a ripple of energy through various regions of the Pacific Ocean that have a huge impact on our weather forecasts from about 40 to 60 days. Okay. So that's basically, that graphic right there is about as basic of an explainer as you'll see on something like this, because it is pretty complex and it has a lot of different intricacies that make it important. When the MJO is cycling, as it should, weather is variable. Okay, we keep the storm track variable. We keep it moving. Every area sees different hints at storms here and there. The problem is when the MJO is not cycling, courtesy of a La Nina, you get stuck in weather ruts around the country, and you could see that when I showed you those precipitation anomalies earlier. So this map right here is a forecast that takes us through the end of September. And what you're seeing in those blue and green areas right there, those are very strong easterly trade winds blowing across the equator that keep the La Nina locked in and even strengthening at times. You have a weak westerly wind over here in the Indian Ocean. It has no effect, no counter effect on those easterly winds. So what those easterly winds do, they essentially keep the MJO from cycling past about region 4. So really the most upward motion in the atmosphere is farther west than it should be. And that makes it incredibly difficult to get variable weather in the western United States, especially the southwest United States and out into the western high plains. And I'll show you how this kind of ties together with the forecast here in just a second. But I think this is something that never gets talked about. And that's a real problem, because this is one of the single reasons why we had such significant drought in the western high plains and southern plains until some areas actually picked up a little bit of rain. The Euro 30-day MJO forecast, all you need to know about this graphic right here is that where you're seeing those lines in the center, the dark lines, the colored lines, when you're seeing them in the center part of the graphic, that essentially means that the MJO is staying very weak and the signal is not strong, and it prevents it from really having a huge impact. Now, those lightly shaded yellow lines, those are all different members of this particular model. So you take all those members into account, and those colored lines are the average, okay? So that's not to say that we couldn't try to have an event, but how many of those yellow lines do you see way out there on the graph indicating a strong signal and one of those signals that cycles through all of those regions? You just don't, okay? So chances are the MJO is not going to be a huge player in keeping our weather variable, at least in the short term. Over the next 15 days, here's the precipitation anomalies, and it's kind of like whoever's dry kind of stays dry, and whoever's wet stays wet. And you can see those anomalies in the Pacific Northwest that are fairly dry, especially for this time of year when the seasons are changing. Parts of Northern California might get a little bit lucky. We still have remnants of the monsoon going on, eastern Arizona, western New Mexico, into parts of Colorado, but you don't have to go too far to the east to run out of it. Look at all of Texas right there that is going to struggle. And really, aside from that say 1 to 2 week period of some rainy weather across parts of Texas, large part of those folks have been shut out. Okay, so it helped out some folks that got it. Absolutely, that's a good thing, but they're reverting right back to the same weather pattern that got them in trouble in the first place, which should be troubling to those folks down there. These are the analog years. Everybody bothers me about analog years all the time, and I know why. Okay, so for those of you that don't know about analog years, an analog year is a year from history that has the same type of weather/climate drivers as what we're dealing with right now. So those years that I have up there are all years where we were dealing with a La Nina and where the PDO was quite negative. So this is October through December, okay, the precipitation anomalies that are supposed to be associated with these types of setups. So you don't see any wetter than average on there at all. In fact, you see the exact opposite. Those yellows and reds are, historically speaking, drier than average areas. And this is a typical La Nina type of a map for the fall and early part of the winter months. Does that mean that these analog years will carry over into 2023? No, it doesn't, because if we come out of this La Nina, well, then we go into something completely different. So during the course of the next month, I will be paring down these analog years and likely adding some and subtracting some to give us a better feel about where we are going forward. forward as we head into 2023. But for right now, as we finish this year, these are the analogs that are very much in play and actually would probably even carry over into January, if to be honest with you. But as I said, in our next webinar next month, because we'll have just simply a better feel with that. You can ask me about the analogs, but again, it's it is a fluid situation over the next couple of months as we see what happens in the Pacific. Climate Prediction Center, their forecast over the next 3 months, it's the same thing. You see where it's dry, bullseyes down there in the southern plains, lower Mississippi Valley. We should start to see an uptick in the precipitation over the Pacific Northwest as the storm track gets more active. But with this particular setup, the models are hinting at something occurring very much like this, where things are dry, where they should be dry, quite frankly, based on the way the Pacific Ocean is set right now. So let's look at the models. North American Multi-Model Ensemble, we'll start with that. These are precipitation anomaly forecasts, okay? So for the month of October, wherever you're seeing the brown, especially the dark brown, that's where your dry signal is the most stout. So you can see that across parts of the Four Corners, eastern Colorado, Kansas, extending out here into the Mississippi Valley. Again, where the areas that have been dry in the Pacific Northwest, we'll probably start to see an uptick as far as moisture goes up there, but that's for the month of October. November, that's what it looks like. And you can see dry. Again, if I could go back to that analog year map and you looked at this particular map right there, they're pretty much identical, you know, in terms of where those dry bullseyes should actually be. You can see the Pacific Northwest actually starting to come into fray. If we look at December, notice how that brown gets beat back to the south and southwest. This year, there are some signals that say, are suggesting that we might have a little bit more activity coming from the northwest. Okay, so that's why you're seeing all the green up there over the northern Rockies and the Pacific Northwest, because that's where the storm track will be most active. During the month of December, we can catch a big storm or two that swings out of something like that, that misses southern New Mexico, west and southern Texas, and the southeast. Okay, the idea here is that the farther northwest and northeast you live, the more active the weather is probably going to be. And you see that trending into January too, across the northern Rockies, the northern plains, and then it's average to above average moisture going across parts of the Midwest and into the eastern Corn Belt. But notice what happens back out here in California. They go back to drier than average, which historically speaking is what should be happening when there's still a La Nina present. If we go to February, same story. Again, you get locked in. What's wet stays wet, what's dry stays dry. And you can see that dry signal is starting to flex again, coming up out of New Mexico and into parts of the western high plains. So by the time we get into March, it's not as bad as it was, but it's still kind of present. And look who's active. Pacific Northwest, northern Rockies, northern plains on up into the Corn Belt. That's March. If we look at April, this particular model suggests that the La Nina will be a weak enough stage where it won't be driving us anymore as we head into spring. That's why you don't see a whole lot of brown right there on the map. Last year, when we looked at these models, there was pretty good agreement that we were going to see some problems in terms of dryness in the western and southern high plains. But this year, if that La Nina gets out of here, obviously that situation would obviously be different. That's one model. Let's go to the Euro seasonal model. Same color scheme, okay? Brown is drier than average, green and blue is wetter than average. So that's October. That's November. Looks very similar to what the NMME was showing, okay? Very La Nina-like. It should, because that La Nina is going to be kicking big time over the next few months. A little bit of relief, Pacific Northwest, Northern California. And then you can see the situation setting up as it should. Pacific Northwest, Northern Rockies, parts of the Sierra get into some snow there. This is December. We go to January, you can see where the action is, okay? Again, favoring areas across the northern tier of the country, and especially once you get farther east in the Ohio Valley. So if I could draw the jet stream on here for you, it would obviously be coming to the Pacific Northwest, rotating through the northern Rockies, missing, the storm track would miss basically Southern California through West Texas. Those storms would kick out of the mountains and they would grab the moisture in the Gulf and they would light up again once you get into the Mississippi and Ohio River valleys. If we go to February, you can see the dryness flex again across the western high plains versus the Pacific Northwest and Northern California stay wetter than average. If we go to March, it's kind of the same thing. Okay. But some of these dry anomalies are not terrible. Okay. If you look at along the Front Range, again, these are in inches above or below average. Okay. So even if you're seeing a little bit of a brown right there, at least you're getting close to average. I know a lot of folks that would love to have an average March and April coming up in terms of moisture, because it's been a while for a lot of my folks that I talk to that they've had that from an especially when it comes to, an agricultural perspective, putting water in the ground early. So that's through March. If we look at another computer model here, it's essentially made up of an ensemble. Okay, so it's just a little different look. But these are dry probabilities showing up here for October, November, December. Again, you see where they're most prevalent. They're exactly where they should be based on history, based on what La Nina is doing, and based on other computer model information. And then if we go to December, January, February, again, much like those other models, that dry area gets beat back to the south and southwest as the storm track becomes a little bit more active during that time, and can hopefully, produce at least a little bit more average moisture during that time. So that's what I've got for you right there. And I am totally open to questions, thoughts, anything you guys want to chat about here. Okay.
Looks like we did have one question, Brian.
Yes.
In the chat here. Why do the models forecast the neutral?
Why do they forecast the neutral?
Yes.
You mean to come out of, why are they coming out of La Nina and heading back toward neutral? I think that's what I'm reading here.
I think so, yeah.
Yeah. The reason why El Nino and La Nina fluctuate, we don't necessarily know what drives it specifically. I will tell you one thing. I do find it a bit odd that the models would weaken La Nina from its current strength right now, given how negative the the PDO is right now. Historically speaking, you want to see that PDO start to warm up or become more positive. And when that happens, it makes it much, much harder for La Nina to maintain itself. Now, historically speaking, again, it usually La Ninas will weaken when we get to spring. And I think that corresponds with the seasonal change that takes place across the Pacific Ocean. When you start to get deeper into summertime, you get the tropical activity, you're starting to push heat anomalies around different portions of the globe. But historically speaking, also, La Nina usually strengthens the most during the fall and early winter, and then starts to come out. I'm seeing another question here. It says, how about the wind through the winter in Nebraska and Colorado? What's the probability of high wind events? Historically speaking, La Nina produces plenty of wind. You guys remember what was going on last spring, right? In those areas? Okay, it was a disaster. It was windy every day. We had a huge wind event on December 15th as well. So when a La Nina is present and it is strong, those high-end Chinook events that blow off the Front Range are more frequently occurring. So I've been telling people, yes, I would plan on some wind. Does that mean you're going to get a catastrophic wind event? No, it doesn't, but I would plan on some wind.
Hey, Brian, this is Tate.
Yeah.
You looked at some of those. We talk obviously a lot about the Pacific and what phase it's in. Those, I guess the oscillations, the AMO and the PDO phases, those couplings that you showed us.
Yes.
Obviously, depending upon which phase the AMO is in, that makes a big difference as well. And I guess, can you remind us what phase that is in right now, and can you give us any hint as to whether there's anything going on over there that is going to significantly change things, or are we pretty much focused on getting this cold water broken up in the Pacific?
Well, first of all, we need the cold water broken up in the Pacific. Okay, but secondly, if you want to talk about the AMO, it's been in a positive phase since 95. All right, so historically speaking, say, well, 30 years from 95, that would put us at about 2025. I would say the AMO probably flips back to some sort of a cool phase within the next, say, well, I would say in the next 3 to 7 years along that time frame. We should start to see something like that happen. So when I'm telling folks this, they say, well, that doesn't help me at all. Well, you know what? It helps me because I'm looking at having to make ranching decisions for my folks' ranch going forward. And if I know that things might get better in 3 to 7 years, that helps me. And that should help everybody that's in agriculture, to be honest with you, because I know that from a planning perspective, that really isn't that long from now, you know. So it helps with budgeting. It helps with a lot of things. So if we and to be honest with you, the Pacific has been in that cold phase since around 2000. So we're coming up 23 years. So the Pacific should also be looking to switch phases over the long haul during that kind of same time frame as well. You know, in the next, say, 3 to 7 years or so. So if those changes take place, then you're pushing those drought frequency anomalies around to different locations. I think that's important information, you know, from a planning perspective, even though we don't know exactly when it's going to happen. And I'll give you a good example of that. So back in early 2014, the PDO went to some of the warmest levels we've seen in quite a while, and it lasted through about 16. We had a pretty big El Nino during that time. Okay, so when I saw that trending that way, I was letting my clients know, like, hey, you know, you probably need to capitalize on these next 2 to 3 years. You know, plant some crops that are high yielding when they get the rain that they need to. You don't necessarily have to focus on the drought resistant stuff like you did from 2010 through 2013. And again, that's a 3-year period right there. So if you're equipping people with that type of knowledge, I think it helps them from a risk management perspective. Even though there's a lot of people that they don't think we know what the hell we're talking about too. And I get that. Okay. I totally understand. Like, well, you can't forecast what it's going to be 24 hours from now. What are you talking about 3 to 7 years? The reason why I'm doing that is because I'm not trying to make the same forecast 24 hours from now. Okay. I'm trying to make something that is a trend. To put a baseball analogy, I'm not trying to run the bases. I'm trying to just get in the park. If you can get in the park, you can make some decisions accordingly.
Yeah, that makes a ton of sense. And it's just difficult sometimes to remember and understand how long the time scales on some of these things are. Like you say, I mean, we've for the better part of, 20, 30 years now been kind of stuck in this rut. And it seems like, and that, these forecasts are super helpful because then you can try and determine, are you going to, locally over the next 60, 90 days, is there anything that is going to break through this pattern and deliver something or whatever? But it's tremendously helpful. I mean, even though the light might be really far down there at the end of the tunnel, sometimes it's better to know, it's better to prep for the worst and hope for the best than I guess the other way around. So
that's right. And with the way today's world is, being in such a mess in certain facets, to be able to say, I know here in the next, say, 5 years, that if this weather pattern changes, I need to have my stuff together so I can capitalize on something like that and really make a lot of hay when I can, because I know that time might not last that long. And I think conveying that type of message to people is important, especially given the way things are situated right now globally.
Brian, I've got a question for you. I know a lot of guys are planting wheat right now, and I know last year we really didn't even have enough moisture to get it up. But where are you kind of seeing, as far as these next few months, or well, even the next 30 days, as far as rainfall and getting this wheat up and going?
Specifically, are you talking Western Kansas?
Western Kansas, Colorado. Yeah, probably.
Well, there was some rain out in eastern Colorado today. There's some rain in western Kansas today. I think there's some folks out there that are getting some rain that maybe they haven't had lately. That'll kind of make them kick it into gear. And because I've been telling people for the past couple of months, I'm like, look, if you live in that region and you have moisture, you may have your planter in the field a little bit earlier than what you want, but I would rather you get that in the ground and get it up for 2 reasons. One, because you may not have the moisture in October if you needed to plant late. And secondly, there's a lot of areas out there, they better get a cover crop up, because if they don't, that ground's going to blow. because as I said, we will have wind. So they're kind of fighting two things right there. They don't want to necessarily dust it in, but there's some areas that are going to have to do that. I'm a little more, as I showed you in the next 15 days with that map, it does show some areas over eastern Colorado, western Kansas, possibly even southwest Nebraska, getting enough moisture to where a lot of folks are going to be able to get that in the ground. So I'm somewhat optimistic. I gave a presentation in Burlington. It was about a month or so ago, and I showed a little bit of long range stuff, and I was like, look, you're going to have an opportunity here in the back half of September. You better take advantage of it, because once you get in October, not only is it getting a little bit late, but you may not have the moisture left.
Yeah, that's good to hear. I know last year, I mean, a lot of that wheat just didn't even come up until March, April timeframe. And so it sounds like looking a little bit better in that time frame, as far as getting a little bit more moisture than last year.
I'm more optimistic about it, yeah. Because as we went into March and April last year, that La Nina was sinking its teeth in again. So it was actually reinforcing the pattern that happened back in the fall. So if we can actually, even though La Nina may still be a little bit present early in the spring, as long as it's not intensifying, that makes a huge difference. If we're coming out of it, that's much better than it sinking its teeth in and going back into it. You know what I mean?
Yeah, that makes a lot of sense.
Yeah.
So Brian, I get your analogy, your trend that you're talking about. What regionally is there anything for us to key in on for base hits annual? I'm in Northwest Colorado as an example in the Yampa Basin, and what history has kind of taught us is the first year of a La Nina actually is wet for us, but the second is very dry. And of course, now we've had 3 years, so we've had 2 very dry years. Mm-hmm. But with across the map here, are there any factors in all of the data that you're showing us, all these oscillations, PDO, all of that we can begin to key in on for our region specific areas to kind of build the base hits within this long-term trend that you're talking?
I'm optimistic for you, at least in the northwest part of the state. Once we get into December, I think that there's some evidence there that you'd be far enough northwest to be capitalizing on some of this storm track that would move in here. Also, if we have stuff coming from the northwest more frequently, there will at least be more frequent storms moving through to give us some opportunities. So, and in fact, I'll go back if I can here to the Euro seasonal model, because I think that was important to what you were talking about here just a second regionally. So if we look at, hang on here because my computer's running a little bit slow, but we'll go backwards with March. Okay, you saw what March was there. There's February. And if we go back one more here to January, you see what I'm talking about there? You see, it's catching the northwest part of the state. The problem is that when we shut California out in terms of a storm track, okay, our juiciest storms, at least in eastern Colorado, western Kansas, right along the Front Range, all the way down in eastern New Mexico and Texas, come from the southwest. All right, so if we shut the door on that southern storm track, they get shut out. But areas farther north can benefit. Northern Front Range, the Northwest, the Yampa River Basin, like you were talking about, on up into Wyoming and parts of Montana. So again, I think this is a testament to if we are coming out of the La Nina, those more frequent storms will at least have a higher percentage of occurring, if you get my drift.
Yes, thank you.
Yep. Anybody else?
Hey, Brian, this is Aaron. So this time last year, it seemed like the La Nina wasn't, it was strong, but what I remember was everyone was like, we just need to hold on. It's going to be a wreck. it seems like the La Nina now is stronger than it was this time last year. And it doesn't seem as extreme, at least for the South and Southwest. Is that purely because the models are,
See it weakening?
yeah, I mean, is that
Yes.
and I guess my next question too is like, we had them on, the monsoons were active this year. They weren't the last couple years. So the difference between what we've got this year versus the last couple years regarding monsoon.
Yeah, I think the models are doing just that. Remember, when these models initialize, okay, they are initializing on the conditions that are occurring right now. As you go out in time, the certainty of those same type of conditions continuing are statistically less probable. It has nothing to do with weather or climate. That's just, simple statistics on how these models work. So historically speaking, we come out of a La Nina in the springtime. Even if it's still there just a little bit, we still come out of it. The strengthening takes place in the very late summer, fall, and early winter. We max it out there December, January, and then we start to come out of it. So history is on our side to do that. The models think that that's what's going to happen. And I didn't show one model today because I think it's an outlier. It actually had us in a full-blown El Nino by April. And I'm like, that's a huge shift. But those huge shifts can take place because when the atmosphere has been in this opposite phase. Now, do I think that would immediately help us? Not necessarily, because I don't even want to look at that right now because that's somewhere higher. All I'm thinking of is just simply getting this to weaken enough to where we can get back to some better variability and also warming the Pacific up. If we lose La Nina and we don't warm the Pacific up, then we're probably going to be sitting in the same boat here again in about a year and a half or 2 years talking about the same damn thing. So we need a couple of things to happen right there. We need the La Nina to go away for sure. Pacific to warm up. When that happens, then we can actually start talking about facilitating some change and pushing these wet and dry anomalies into different spots.
Gotcha. Thank you.
Mm-hmm. Anybody else?
Hey, Brian, just for one, this is Tate again, I guess to satisfy my curiosity. I mean, on these models, specifically some of the ones that are more near term until now through the end of the year, I guess you may need to flip back through them and kind of refresh my memory, but there wasn't anything, I mean, even in the best case scenarios, kind of like where we're looking there right now with the Pacific Northwest and the Cascades getting above average moisture. That's above average, but I mean, you're not seeing anything. I mean, I don't see any values on there that look extreme. Like there's like the places that are forecasted to get better than average precipitation over the next few months. It's not a super strong signal, I guess is what I'm saying. Is that accurate?
Well, the blues there go off the scale across parts of Northwest Washington. You'd be in excess of 3 to 4 inches above average, and some of those some more high end. Now, that's not necessarily a wider area. I'm not necessarily focused on the specific anomalies, though. Okay, I'm focused on the model that is actually painting an above average anomaly in there. Because one storm, you could be 10 inches above average. You know what I'm saying? Because and that's really not the model's forte. The model's forte is actually giving you an idea of who may see above average and below average conditions during that time. So I wouldn't necessarily focus on those not anomalies specifically in a numeric form, if you get my drift.
No, that makes sense. And I was just trying to get a relative sense of it. I guess that's kind of, I mean, that jives, I guess, with what I am kind of reading into it, I guess, and understanding it is that we still haven't flipped the signal to where the overriding thing is going to be trending towards above average as opposed to below. It's really, we're still trending below average, and there's some things that might happen, intermediate to in specific areas to change that. But otherwise, we're still, trying to get out of this rut.
Yeah. And I think too, and the thing that I always tell these guys when they're looking at, oh, it's just all brown. And I'm like, look, even in a drought, there are still storms. Okay. And if you're in a drought and you catch one big storm, I know a lot of guys that raise wheat in eastern Colorado, western Kansas, down in the panhandles. They can make wheat crop with 2 rains. So at least here in the Western High Plains, it's largely about timing versus specifics and moisture. I know that that's not the way it is everywhere. But I tell those guys, I'm like, look, if you get moisture and you can get that wheat in the ground and get it up, go ahead and do it. Do it up, and we'll see how things go going forward. A lot of guys did get lucky in that regard. I spoke to at a Texas AgriLife conference earlier this week down in Canadian Texas, and they're in Hemphill County, and they are an island in the Panhandle. There were so many areas of the Panhandle that were completely droughted out, and for whatever reason, Hemphill County had plenty of rain, and they did just fine raising dryland wheat down there. Their corn looked fantastic, whatever. So again, there's always going to be these anomalies that, are just going to happen. Consequently, you can also have the reverse of that happen too. Everybody's wet, and then you're the guy that's dry. I've seen that happen before too, So I think Aaron was asking me a question. He said also, which model is currently my favorite for long range forecasting? I would say the Euro seasonal model here is probably my favorite. I had some clients that needed to move some cattle around last spring. In March, I told them they were going to have a hell of a monsoon in Arizona, New Mexico. He had a ranch in southeast Arizona. He moved all his cattle out of East Texas, and it's perfect for him. So I think it also, you need to think about how similarly these models, the NMME and the Euro seasonal model, were tied together here with their forecast. And I think that's a testament that they're both keyed in on how strong the La Nina is right now, and they're perpetuating it out in kind of a similar time frame. So when we get into springtime, obviously you have the seasonal change that accounts for weather variability. If you have the La Nina weakening, that's another thing that can account for weather variability. And I'm far from an optimist when it comes to things being dry like this in places, but I do actually have a little bit of optimism as we head into the spring.
Got it. Thank you.
Mm-hmm. And I hope, my goal wasn't to bore anybody with stuff at the beginning, but I oftentimes will use that as a table setter for a lot of folks that may or may not know what's been driving this. And not only that, but how long it's been driving, and the changes that have gone through. So, when things are stacked like this, you get in a rut, that rut can last for quite a while. As I always say, there's a reason why the Anasazi Indians were driven out of the Southwest. They didn't have any water, Look back in history, some of those droughts lasted for over 200 years. So to put that in perspective, there's a lot of folks in southeast Colorado that's where they've been in a drought since 1999. We're talking 23 years or something like that. If you look at the statistics, there were some wetter than average years in there too, of course, but most of their years have been drier than average as of late. And you can thank the PDO for being stacked the way it is for that reason.
Well, it definitely makes me think that precipitation insurance based on an average is probably another good bet in 23.
I told everybody that I talked to when I was speaking in Canadian earlier in the week, and it was specifically Gordon Clark sponsored me down there for my talk that I was giving, and he that was one of the questions from the audience, and I'm like, look, if you're if you've got grassland in the Western High Plains, and you look at the history where your prospects of being drier than average are 75% of the time, I don't know why you wouldn't do it. There are specific years where I have told clients you don't need PRF insurance this year. Those years, I would say that there's probably been out of the past 20 years that I've been doing stuff like this, there's probably been about 3 years that I have told clients that I was so certain that we weren't going to be drier than average. But again, here in the Western High Plains, you know, you can be in a normal weather pattern, it's still going to be dry, and you're still probably going to capitalize on some of those intervals, you know. Aaron was saying, if I had to bet on 3 analog years right now, which ones are they? Well, I guess I would have to look at 21. Okay, so 2021, that was last year, because we're very, very similar to where we are right now. I think if we look at 2008 was in there as well. Man, you know,
I won't hold you to it. I'm just curious. What
yeah, I mean,
30 days.
And I hate saying, you know, I hate saying stuff like, you know, 2010, 11, 12 in those areas, because you could look at that and you'd say, well, that's the last triple dip La Nina we had. So shouldn't it stand to reason that that's how we should play out of this? And I mean, I guess there's logic in that, but I remember, you know, a hell of a drought in 2011 in Texas, and everybody was saying, oh, it's going to be drier than average, including me. I thought it was going to be drier than average going forward. Well, we got a little bit of a break in there at the end of 11 and the early part of 12, where the MJO went crazy for a little bit of time, and it pulled a lot of that area out of drought. Now that it went right back in it later in 12 and into 13, but to see that little blip that happened right there, you know, that blip is a huge blip, and that's something that a lot of models can't forecast. So I don't necessarily want to compare it to that, but if you looked at history just point blank and say, well, when's the last triple dip we had and how we came out of it? Is it possible we do that? Sure. Yeah. So if you're looking at 21, we can go in reverse. We can do 2008. We can look at that interval in there from 2010 through 2012, and then 2021. I would say that those are probably the leaders in the clubhouse right now. And the reason why I say I throw that analogy in there in 13, because in 13 we warmed up the PDO significantly from the first part of 13 to the early part. From January of 13 to January of 14, that PDO completely flipped on its head. It's possible it could do that again. Okay, especially if we were to do that, I would say that there would be an El Nino that coincides with that. You look at what the models are forecasting, they're kind of suggesting something like that. So it's not out of the realm of possibility that happens. And when we talk again in November, I'll probably have those years narrowed down pretty significantly.
Thank you.
Yeah.
Well, Brian, that's really informative. I know that helps me. And one of the things too, and I know that this, you know, the situation always changes, but I guess I can always have my fingers crossed for you. Mentioned that quick flip. You mentioned one of those models that you didn't show that was showing, hey, we're going to be out of this thing by April, and it's going to flip the other direction. I guess out of curiosity, is there any kind of frequency for that type of precedence? I mean, for just kind of a wild card type thing where it just flips out of the phase. I mean, almost comparatively speaking, overnight.
In
the historical record.
Yeah, but they're pretty infrequent. I mean, you could look at what happened. I guess you could look at what happened back in the late 90s, early 2000, where we were very chilly, and then we kind of briefly came back up, and then we went right back down in it, I think around 2005 and 2006. And if we, it'll take me a second to go back to the graphic. So bear with me here, but we'll get back there and I'll kind of show you. In fact, tell you what I'm going to do here. So I'm just going to do this. Hopefully I didn't crash anything. Got about 16 different things running on here at once. But there we go. So if we go back 20 years right there, okay? So you see over here around 2000, okay, I'm going to play this again so it's up there. Okay, so if you look over here around 2000, we're cool, negative, but look what happened right there. Late 02 and 03. We've got a nice little bump right there. Okay. Look what happened here back in say late first half of the 2000s. Okay, from about 07 to 9. tried to come out, but look what it did. You see how hard it is for these things to change when your predominant pattern is locked in there. As I said, you come back here to January of 13. Okay, we were way down here, and you see where we were up here by January of 14. I mean, we completely flipped it on its head. Do I think that's possible with this scenario? Sure. I mean, it's been a while since we've actually had the PDO be positive for a period of time. But given the fact that we have a pretty small sample set of that happening, what's my confidence in it's going to happen coming up? Pretty low, you know? So I think the key, and the key is for me, it's like I always tell people, I'm like, look, I don't ever pretend to be the smartest guy in the room with something like this, but I do know what I'm looking at, and I do know what will facilitate a change like this has to actually start happening before we know it's going to happen. And when I see it happening, that's when I alert people as to what to expect because of that change and to start making decisions. I don't think there's anybody on the planet personally that's going to tell you when the PDO is going to flip. I just don't think so. If they knew that, they'd already be talking about it. You know what I mean?
No, that makes a lot of sense. I think the thing that I'm always focused on is again, unless you know, I tell my customers, unless Brian is jumping up and down, waving his hands, saying that, hey, this thing is we're going into a different you know, phase entirely here, that realistically, I mean, you're probably never going to get the timing right if you're, you know, trying to guess at it. And furthermore, the most important thing as far as where your risk management decisions need to be for next year is based on what's your situation on the ground now.
That's right. Yeah.
You know, and is there anything, I mean, we're going into winter. I mean, so there's nothing outside of just an awesome winter. I mean, there's nothing that is going to realistically change our prospects at this point for next spring. And so, you know, we're already talking about, you know, too far out for the models to show us anything in the sense that it is, like you say, unless it was that one model that we were looking at, that is the 1 in 10 chance of it totally turning on its head. But otherwise, I mean, if you're starting from a position behind now, I mean, you really cannot afford for this trend to continue next year. And so it's probably not a good year to gamble, in other words, on you know, pulling back acres or whatever in PRF. Those years, I'm hoping, are ahead so that we don't have to manage as much risk every single year. But right now, it seems like you know, the smart money is probably on more of the same.
Yeah, depending on where you are in the country. Yeah, absolutely. And it's like I said, that, you know, the tough thing about the El Nino La Nina thing is, like, yes, they are drivers. There's no question about it. But they can be largely different from each other year to year. You know, I've seen La Nina episodes that loaded up on the Western High Plains. Okay, so are those the frequent occurrences? No, they're not. They're the aberrations. So when you look at simple statistic, you'd say, well, what are the odds of that happening? Pretty low. So why would I want to bet on a pretty low odd at that point? Well, it's like doing a horse race. Okay, well, because maybe I can capitalize when everybody else can't. Do you have the money to do that? Do you want to put yourself out there like that? Not many people want to do something like that. And I just don't think that that's good business. Okay, that's just not sound thinking in that regard when you're looking at statistics or analytics in that way, which a lot of people do when it comes to PRF and managing risk. Okay, so yeah, I mean, when I'm excited about the pattern change, you'll know it.
Excellent.
Yep.
Well, did we have any other questions in chat? Any other questions out there from the participants for Brian?
Nothing.
gave us the information we were looking for, or at least whether I don't know if it's the answer again, like you said, but I think everybody's confidence level in what you're telling us. I mean, and all the data seems to back it up. I mean, it just it's pretty high. And I think, like I say, I mean, I'm always going to have my fingers crossed for that bump there where, it can just totally, flip the other way. But like you say, the likelihood of it is pretty dang low. And so I think that's, I'm going to try and research these slides a little bit more later. But other than that, I think that, that gives me kind of the firm base that I need anyways to help some of my customers make some of these decisions this fall.
Good. And if you need some personal touch, just chat with Aaron or whatever, or send me an email and we'll get in touch, and, we can do a special meeting. If you got a big client or whatever you want to talk to directly and have me on the phone, then we'll do something like that. But give me a little bit of heads up. These next 2 months for me are pretty nuts. So the more heads up on something the better. But I think our next webinar here is basically, I think I told Tara, I think the 10th. I think we're going to do October 10th with something like that. So that's the day I'm targeting. Most of the new model stuff comes in completely by the 8th, and then it gives me a couple of days to sort them out. And then, so we're going to target Monday the 10th at 7 in the evening, I think is what we're going to do.
Well, we really appreciate this, Brian. This new format's really great for folks to ask questions, and we'll definitely be sending out, announcements and save the date type of stuff. This will also be recorded on our website for folks to consume later on if you want to look at that and or even pass it on. But yeah, we just want to help and serve everyone out there and our customers and producers. So we really appreciate this opportunity for you to deliver the goods. So
absolutely. We'll have some good stuff coming up in a month too. And the deadline, when's the deadline? It's just December. Is it December 1st?
That's right.
Okay, so December 1st. So, I mean, that gives us a little bit of time here. And I know, I've got guys pulling on me for this, that, and the other thing. But as I always say, I'm like, if you let this breathe a little bit here, I would always let it breathe a little bit so I can give you a little more of a definitive answer as we get closer, instead of just shotgunning some stuff out there saying, hey, all of this is going to change in a month. So that's why September is a good time to start this stuff. October even better, because we've got a fresh look at the models. We have another month to see how the sea surface stuff is going on, and we'll be and we'll target again around November. Probably November 10th is the same thing too, for doing something like this too, in that ballpark.
You bet. Definitely a good primer to keep the momentum going. So
yeah, absolutely.
Well, I think we're finished up here, unless anyone has any other questions.
Thanks again, Brian.
Thank you, Brian. Thank you, Aaron and Tate team. Appreciate all the assistance that you've given us over the years. It's been a successful collaboration.
That's what we like
Thanks
to hear.
a lot, Steve. Okie doke. Until next time, be on the lookout for emails or text messages and Facebook notifications.
Very good. Thanks, guys.
All right. Bye-bye.
Take care.